Hello, everyone. Hello and welcome to this, which is the fourth Clopen Mic Night. I did not think we would get past pi. I'm being honest. I'm very impressed that we've made it to four. Thank you very much for joining us. For those of you who are watching, my name is Katie Steckles. I am a mathematician, and I'm here to bring to you an evening of mathematical stuff and mathematical adjacent stuff and other things that will hopefully be enjoyable to you, some people who came to a maths thing. Before we start, I want to say a couple of sort of vaguely housekeeping-y things. First of all, this is a show on the internet. We are aiming this show at, I guess, an adult audience, which is why it's happening at bedtime. So to warn you, this may include swearing. Let's be honest, if you're doing maths, it happens, doesn't it? And we're aware that there might be some people watching in other time zones where people may have kids present in the room and that kind of thing. If that is the case, please be prepared to explain to them any words that they might not have heard before, mathematical terminology and that kind of thing. There is in the description underneath this video, if you have a look there is a very sort of brief code of conduct type paragraph, which I will just check in with by looking slightly to my right. But it essentially says, please, be nice to each other, look after each other in the live chat. Don't be exclusionary, don't be horrible or mean or anything. If you have any issues with anything that's happening in the chat, you can drop us an email, hello@clopenmicnight.com, and let us know if anything's going badly, and we will keep an eye on that to be able to keep things going. We've got a couple of our team are in the chat as moderators as well, so you can they will hopefully keep on top of stuff in there as well. But just to make sure everyone's happy, I will, of course, as is traditional, commence by explaining what the word Clopen means, because it's one of those maths words. When you have a thing in maths like a set or an interval or some kind of object, it can be open or it can be closed. And if you're not sure what either of those things mean, it's a really nice and interesting thing to learn about. So please go and look those things up. But if you do know about those things, you can have an open thing or a closed thing. And in their infinite wisdom, mathematicians have decided that if something has the property of being both open and closed at the same time, which is possible because of some fiddly technical definitions, they have created the word Clopen to mean both open and closed at the same time. Obviously, what else was it going to mean at all? And we've decided to call this event a Clopen Mic Night because it's a bit like an open mic night in the sense that we've got a variety of different things going on. There's no way to know what to expect. Anything could happen in the next remaining 56 minutes of the hour. But it is also not an open mic night. It's also, there's no such thing as a closed mic night, but it is not an open mic night in the sense that none of you watching will be able to just jump up and do a type 5. But we have both curated and invited and collected a group of people to put this together, which we think will form some kind of interesting combination. So hopefully there will be something for everyone in here. If any of the acts are not your cup of tea, they won't be on for that long, so just hang on and wait for the next one. That's absolutely fine. But hopefully this is going to be an enjoyable hour for all of us. So remaining bits of admin to say. First of all, if you would like to get an email next time we do one of these, because we do know that social media is dying, so it's probably easier to just get on our mailing list. So if you head to our website at clopenmic.com, then sorry, clopenmicnight.com. Then you've got a link there to jump on the mailing list. You can also, if you really must, follow us on Twitter at Clopen Mic. And you can also find us on Mastodon at Clopen Mic Night. And we're on mastodon.xyz. So hopefully links to those things will appear in the chat imminently. We have 4 acts for this evening. We have 4 acts, all of whom have been listed on our website, but I will introduce each of them as we get there. They're going to do sort of about 8 minutes each, but we'll see how we get there. And hopefully all of that will fit within an hour. We'll see. And the final piece of admin to say is that, of course, you are watching this on the internet, and like almost everything on the internet, it is free. You are absolutely welcome to watch this show for free if you would like. But the thing to bear in mind is that everyone who's taking part in this is giving up their time to do so. And we're hoping that in order to sort of thank them for their time and thank them for the effort that they put into this, that we will have a donation bucket. So we have essentially a tip jar, some kind of mathematical donation bucket. We've gone for the website Ko-fi. Which we've checked, we looked up the pronunciation. It is pronounced Ko-fi, but it's Ko-fi. Again, a link will appear imminently for you in order to click on that. But the ko-fi.com/Clopen Mic Night is the place to make a donation. We thought since, mathematicians are very much into coffee, it would be an appropriate thing to do. We're turning coffee into donations, I guess, or theorems, or whatever you want to do. But it is a way of thanking the people who've been involved in this. So if you were going to go and see a show or something, think about how much you would spend on a ticket for a show to get an equivalent amount of enjoyment. You're very welcome to wait until you've seen all of the acts before you make a value judgment about how much this was worth. But if you would like to, well, I mean, I don't want to make you feel like, pressure here, but someone literally donated £5 yesterday. That's how excited they were about this show. So we've literally already had a donation in from someone. But as I say, it's totally up to you. I know at least one of the acts tonight is planning to donate any fee that they get for this to a charity. So, it will be just a little token to let people know that you've enjoyed yourself and to support what we're doing with this as well. And hopefully it will mean that we can carry on doing these in the future. So that is all of my introductory things. I believe it is time for me to bring on our first act, which I will do by saying, hello, Tanya. And Tanya will magically appear. Hello.
Hello, Katie.
Hello. Welcome. Welcome. I will leave you to it. I'm going to disappear and hide in the depths of the internet, and we will see what it is that you brought to show us. Thank you. Have fun.
Okay, brilliant. Thanks. Okay, there's the usual sharing of the screen. So can I just get a quick sort of thumbs up or some other display of acknowledgement that you can see those slides? A little heart on YouTube or something like that. So
Yeah.
I chose a grey background to try and reduce visual stress. There are some bright screenshots and there is a bird making eye contact at one point. If you're a bit funny about that, then please look away. I was first asked to give this talk way back in June 2022, but my schedule was like a little bit busy, so wisely I agreed to this autumn instead. But it's now winter, and here we are. I'm a mathematician of sorts, but I also get very interested in absolutely everything, and I mean everything. Which is why I haven't actually written the talk, because I get terribly distracted, you see. And so knowing this, I told Katie and Matthew that I would do a talk about a series of interconnected rabbit holes, because knowing myself very well, I am the easiest person in the world to distract. And I thought, I know, okay, let's just open up the email from the organisers and check, what I said I'd do, how long it was for, start there. So I pick up my phone with the intention of checking my email. And there's a notification. There's a new series of Vigil on, which is cool. That's the one with the submarine, right? Phone in hand, not sure of myself. I pop open a window and I have a quick rummage around the internet. And yeah, it's the one with the submarine. But don't worry, there's no spoilers for either series, I promise. Now, submarines are cool, but I've never seen one. I wonder how you go about seeing a submarine. Yes, you can guess what happened next. Now, you would think that there's a ton of really interesting places that we could go from here. Looking at that, oh, hang on, have I got the laser pointer? Let's see if the laser pointer will work. There's sonar, that's kind of cool. Echolocation, that's also a cool thing to look at. And a thermocline. Sounds interesting, but look, there's a picture. And my basic brain, with its gut feeling led by the visual shinies, my brain went for the picture. And there's a boat there lowering a cabley thing down. And I'm sure when I watched Finding Nemo, which, as we all know, is a documentary, there are cables in the sea. Where's my pointy thing gone? Oh, I'm still on the laser pointer and I don't know how to get off it. That's a good start, isn't it? There we go. So I am not the only one to curiously think about this, because I was thinking about cables, but these are internet cables. But boats have Wi-Fi. The last ferry I went on had Wi-Fi, and we all sort of have Wi-Fi because I'm sure there's satellites and things, but are there undersea routers? How do they? And then I found this map and I thought, oh, this is good. There is a whole map of undersea cables and they've all got amazing names. Like some of them are like super awesome and some of them are just like named after the company that put them down. But submarine cables, the ground's grey, the wet bits, the water. That's the white bits. And then I thought, if I look really closely, there's this rainbow network of cables everywhere in the sea, and the fishes must be tripping all over them. But there's one right sort of in the middle at the bottom there that seems to just go to nowhere in the South Atlantic Ocean. So, of course, I then have to bring up the maps. And I found out that there's this massive volcano with a tiny settlement on it, which is part of St. Helena, Ascension, and Tristan da Cunha. And because of the cables, it has internets. But if you look really closely, there's where the people are living just up the top there. And I had a little zoom in, and of course, my brain went, oh, thatched house museum, lava field. Not the best combination, but I got distracted again because where were we? Internet. Oh, yeah. What do we have before the internet? What did people do for sending messages and stuff? Pigeons? No, there was something before the internet, but after pigeons. Did you know there's a secret pigeon service as well? In the war, it was a part of MI14, which is now MI6, I think. But there's a whole book about the secret pigeon service, but that's a whole different rabbit hole. So pigeons, 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 telegraph, something like that. No, not that one. That's not the one I meant. Sometimes we go down little rabbit holes and they're a bit of a dead end. So, yes, there we go. So, what I found out was looking about the telegraph, turns out on the internet, there exists a document, in fact, many documents, because it is the internet after all, that tell the tale of people not wanting to pay money. It says, if you squint a bit, because my screen's not that big, we have ample facilities for handling your business. And I thought, whoa, what are these ample facilities? Because with the telegraph, you pay per character. Think of the early days of Twitter, which I will not ever call anything else, when you had just 180 characters. No, another dead end. So back to the character limit thing. When I had my first phone, it held 10 texts, just 10. So even when we moved on to phones, characters were stupidly valuable. But these people back in 1894, this is the front page of that document I showed you earlier, they had a plan. And before I move on, I really do boggle about how many books from past times are on the internet for free. And we really ought to be supporting those who archive stuff like this. Librarians, internet librarians, we salute you. I had to do the Arnold Rimmer salute because I can't actually remember how to salute properly. But anyway, seriously, the Internet Archive has over 7 million books that you can just read right now. 7 million. But I'm distracted again. Back to the book. It's a bit blurry, so I'm going to read it out loud in my very best 1894 voice. And bear in mind, I know what a voice from 1894 sounds like because I have a wax cylinder with the earliest known recording of what used to be Duolingo. I digress. I've gone down another one. So, the value of this code will be seen at a glance. We will suppose that the friend abroad is in Paris and is about to leave for London and wishes to apprise his friend at home of that fact. He turns to the index and finds sentences beginning with am going to, am leaving for, etc. are to be found on pages 80 to 82 and then makes up the following message, Ingrate, London, Tuesday, which, when translated by the receiver, means I'm going to London and expect to reach there Tuesday morning. Telegram sent to me there will reach me promptly. In this message, 20 words are sent at the cost of but 3. I mean, okay, so this whole book is about gaming the system. I like this. It's kind of information compression. Or indeed, we could fall down this rabbit hole very immediately. Absconding business is very bad. And I did fall down the rabbit hole, which is why 3 hours later, having devoured the entire Adams cable codex, and yes, there are other brands of cable codices, please do search for them, I found myself back in the room thinking, hang on just 1 minute. Without the codex, you didn't know what they were sending. So this was kind of cryptography of a kind. So we have other things that are cryptography, hiding in plain sight, a compressed version that means something else, the humble QR code. And you can try it if you've got your phone to hand. But if my kid had made this slide, you'd all be watching Rick Astley right now. But luckily I failed at replacing it because I didn't know how I, as a basic human, could make one of these. So obviously I looked it up, how to make a QR code by hand. Turns out, of course, there's a project to hand make a QR code, and it's amazing. There's this artist called Anuradha Reddy who makes all sorts of plain sight cryptography. And one of the other things they made was a machine readable crochet cryptography key. And cryptography keys are what you need to communicate with a submarine. And we're back to Vigil. And that, dear listener, is how I got distracted by the internet and forgot to write an actual talk. And you may be wondering where the maths is in this, but things being linked together is a whole game in itself. There's one where you start at a random page in Wikipedia and you see how few jumps you can get to a chosen endpoint. So my challenge to you is to get from Source Columba, which was the code name for the Pigeon project, to Rick Astley in as few jumps as possible and tell me about it. And I think that's coming up to the end of my time. So I've been Tanya Fish, and you've been very patient listeners. Thank you very much and good night. And you can find the rabbit holes at the following address for distraction at your leisure.
That is amazing. Thank you so much. And if you can just kind of imagine a loud round of applause happening now at this point, because that's the only issue with this is that you can't necessarily hear the applause. But
Well,
I'm
this is
imagining,
how you clap in sign language, and this is how you
yeah,
cheer.
yeah.
So we
So
could do
yeah, we can do a
like
bit of
that.
this, but if you're imagining, the audience watching, I'm sure they'll be dropping messages in the comments now. And thank you for all of this. And we'll also make sure that link goes in there as well. That was so good. I really enjoyed that. Like this idea of kind of basically cheating the system. This is always what people do, right? That whatever system you give them, they'll always find some way to kind of find a way around it. And I just love the idea that you're receiving these absolutely incomprehensible telegrams. They're just like, what is this person saying? But obviously, if you've got the right codex, it all makes sense, doesn't it? I
And
love it.
it's how I will communicate from henceforth and forthwith.
Absolutely, yeah. Like, oh, you're putting a character limit on this social media platform, are you? Well,
Challenge
I'll
accepted.
get my codex. Yeah, I love it. Absolutely. I also enjoy making QR codes, incidentally, and so far I have discovered that you can make quite a nice QR code out of perler beads, hammer beads that you iron. If you get the
Yes.
black and white ones, you can construct a QR code out of that. I've also made a QR code with cross stitch, which is obviously you get like a nice grid and you can do that. This is just incredibly fiddly, like it has to be basically right. There's a bit of error correction, but it has to be pretty good. And I've also made a crossword that was a QR code which it was ridiculous. And at the end, you had to shade in the different letters, different colors, and you ended up with a QR code. It's a lot of fun. There's a lot of fun to be had here. I can't believe you were thinking there's no maths in this because there's all the information theory about condensing information down and compression and all that kind of stuff. It's fantastic. If anyone is, I don't know why anyone would be, but if anyone was wondering about Tanya's mathematical chops, Tanya started the Sheffield Maths Jam, so that's a claim to fame. The
True.
Sheffield Maths Jam's now been taken over by one of my former students. So if you are in Sheffield and you haven't heard of Maths Jam, or if you're anywhere really and you haven't heard of Maths Jam, mathsjam.com is the website. You can find out about doing maths in the pub with people. But I'm going to say thank you very much to Tanya. And if you would like to disappear back into the recesses of the internet, you may do that. And the other thing that I was going to add before I bring on the next guest is that, as Kevin has correctly pointed out in the YouTube chat, we're also on Instagram. And I'm going to forgive myself for having totally forgotten this because it's a relatively new development. So We only recently set up an Instagram account just because, you know, how social media is dying. We thought we'd try and branch out a little bit. And we've had a little bit of help behind the scenes from one of our previous acts, actually. So if you remember Eliane, who came and talked about some cool stuff in one of the previous Clopen Mic Nights, Eliane is now doing our Instagram. So if you're seeing excellent, wonderful, cool videos on there, that is why. And we're hopefully going to try and keep up posting on there, maybe posting little snippets from some of these shows as well. So please follow us if you are an Instagram user. And again, we'll make sure that the link is further up if you scroll back, but we can stick it in again at this point if that is useful. So I reckon probably a good time, as good a time as any, to bring on our second guest. So hello, James. Hello and welcome. So James, I mean, you've done a lot more live streaming on the internet than I ever have, so I imagine you're just going to take this away and absolutely smash it. But James has his own Twitch channel, which we'll put links to in various places at the end of this. But I'm just going to let you get on with it. So go ahead, take it away.
Cheers. Have I remembered to unmute myself? I probably have.
Yes.
Oh, great. Thank you so much. Hi, everyone. So yeah, I've started a Twitch channel. It's still really small, but already one of the viewers on my Twitch channel has done something really cool. My plan is to try and show you the cool thing that a viewer did. The only problem is that I need to give you the context of everything that happened in the Twitch stream. The Twitch stream was 2 hours long, and Clopen Mic Night means I've got 8 minutes. Luckily for me, 8 is a factor of 120, so it's easy to work out. It's exactly 15 times as fast that I need to talk. So I'm going to try and do everything from 2 hours in 8 minutes. Let's go. First, let me change into something more comfortable. There we go, that's a bit better. It's a bit less of me, a bit more of the maths. Okay, so multi-perfect numbers. You've maybe heard of perfect numbers before. They get a lot of airtime, they get a lot of press. Everybody loves them, they call them perfect. Multi-perfect numbers are slightly different, and I'd like to try and show you what they are. I've got a table here, I've got some numbers. I'm going to work out the sum of the factors of each number, and then do this kind of ratio for the sum of the factors divided by the number. Okay, first one, I reckon I back myself to do this one at 15 times speed. 1 has only got one factor, which is the number 1 itself, which gives us a nice ratio of 1. Great stuff, we're off to a fantastic start. 2 is slightly more interesting. It's got 2 factors, 1 and 2, for a ratio of 3 over 2. 3 has then got factors 1 and 3 for a ratio of 4 over 3. 4 is kind of even more interesting. Its factors are 1 and 2 and 4, which gives us this rather nice ratio of 7 over 4. 5 gives us 1 plus 5 is 6. 6 is 1 plus 2 plus 3 plus 6, which gives us 12. 12 over 6 is 2. I realise I've forgotten to put the ratio in on that one, which gives us this kind of number, exact integer 2. That's a perfect number. As I say, they're pretty famous and cool. Get a load of airplay, get a load of this. Wow. 7 is pretty nice as well. All the primes have got this structure that you've maybe noticed, that they give me this nice n plus 1 over n kind of thing. I want to do 8 as well. 1 plus 2 plus 4 plus 8 is, oh gosh, 15. We're now stretching my powers of mental maths. The idea is that if you keep going, you might discover more stuff. And fine, you discover more perfect numbers along the way, more things like 6, where the ratio is exactly 2. But something else you discover eventually, if you go like quite a long way, so you discover the number 120. 120 has got quite a lot of factors. In order to do the sum, I need to show you a quick trick for expressing the sum of the factors. It works like this. The sum of the factors factorizes, which is one of those facts that's got the word factor in it too many times. It's easy to remember. It's the factor factorized fact. It works like this. So if you look at the sum here for 6, each of these factors is either a multiple of 2 or it's not, and it's either a multiple of 3 or it's not, which means we can kind of factorize it like this. Things might be a multiple of 3 or they might not, and they might be a multiple of 2 or they might not. Things get a little bit more complicated for bigger numbers, but only a little bit more complicated. The factors of 120, well, 120 is a multiple of 5. Its factors might be a multiple of 5, or they might not. I put a 1 here to represent all of the other factors that are not divisible by 5. Kind of nice thing about the structure of the factors is that the ones that are a multiple of 5 are each exactly 5 times as big as the ones that aren't. 120 is also a multiple of 3, and it's got this factor in it, for how its factors might be a multiple of 3 or not. And it's got a large factor here because it is a multiple of 8, which means its factors might be a multiple of 8 or 4 or 2 or not even at all. But the sum of the factors factorizes really nicely like that. You might recognize this bit being the sum of the factors of 8. These terms are higher above as well. These are, just to be clear, these are different brackets, different terms for separate primes. 5, 3, and that's 2 cubed. I'm beating around the bush because I think I've got to multiply 15 by 4 by 6, which gives me 360 for a ratio of exactly 3, which I think is even better. Okay, it's not a perfect number, it's not exactly 2, but surely 3 is like even more impressive than 2. Wow, it's some of its factors is exactly 3 times as large as the number itself. And I've skipped down to 120 because that's the first time that happens. But it's not the last time that that happens. There's more of these. They get large quite quickly. We have to look at really large numbers before we find any more of these things at all. So I want to show you a kind of game that you can play to construct them. Right, here's how the game works. You start with a power of 2, like for example 16, and you look at what would go upstairs here in the ratio. So this would be the sum of the factors of 16, which gives me 31. Now that's not an integer, it's sort of annoyingly close to 2, but we can fix it. Bob the Builder, can we fix it? Yes, we can. We can instead consider number 16 times 31, which will give us this. You see the separate primes behave separately, and those factors kind of multiply together, taking numbers from the table above, if you like. And that gives us exactly 2, so we've built a perfect number, 496. If the thing that you get above your power of 2 is not itself a prime, you can still fix things by multiplying downstairs by appropriate prime numbers. Now you can put anything down here like 101 if you're feeling mad, but how are you going to cancel out the 101? You don't really want stuff downstairs. You want to choose primes that will maybe cancel nicely, like 5 is pretty good. 5 also provides upstairs here, this number 6 has a factor of 2 to cancel. Provides us with some 3s as well, so maybe we could cancel the 3s by introducing a 3 squared into our number. So now we're thinking about the number 8 times 5 times 3 squared. It's sum of factors factorizes, and we'll get upstairs here a 13. So things are not going super well because I've still got too many 2s downstairs, but I can keep playing the game. I keep considering larger and larger numbers, bringing in more and more primes. And if I do that, oh my goodness, I end up at this number, which is the number 32,760, which is 4 perfect. Its sum of factors is exactly 4 times the number itself. And the thing I like about this game of adding in extra factors to try and cancel things out until eventually you get enough powers of 2 upstairs to cancel your initial starting power of 2. The thing I like about it is that it builds such large numbers without ever really thinking about listing their factors. This is pretty cool. The thing I wanted to show you is that one of my viewers went home and she calculated the following. She started with 256 as a big power of 2. Now, its sum of factors of 256 is 511, which is a pretty scary number. This is not quite a whole number, but we can make this a whole number by multiplying by, oh my goodness, 73 downstairs, which is a good choice because it cancels a factor of 73 up there. Yeah, that's got a factor of 73. Brings in a 74. Okay, new challenge. Get rid of some of these factors. Bring in a 37 to get rid of the 74. The 37 brings in a 38 upstairs. That's how primes work, I guess. They always bring in one more than the number downstairs, which has got a factor of 19. So we can keep playing like this. Not quite done because I haven't got enough factors of 2 upstairs. So she then multiplied by 8 over 7 using the fact that this has got a factor of 7 in. And then 6 over 5, and then 4 over 3 to get the following number: 1,379,454,720, which is another 4 perfect number. Its sum of factors is 4 times the number itself. I think that's ridiculously cool. It's a 10-digit number whose sum of factors I have no chance of working out just by hand by listing them. We know it's exactly 4 times the number itself. If you want to try this yourself, you just need to start with a big power of 2, find out what happens upstairs, and introduce more prime factors. They've got to be different every time. You're trying to cancel things out to eventually end up at a whole number. So that's a challenge for you to play at home. Just to give you some maths, the kind of rough expected number, and people really don't know very much about these, but for ratio 1, there's only one of them, we've already seen it. For ratio 2, those are the perfect numbers. People think there's probably infinitely many of them. For ratio 3, people think there's exactly 6. For ratio 4, maybe 36 of those. So then you see this pattern, you think, ah, yes, powers of 6. It's 6 to the 0, 6 to the infinity, 6 to the 1, 6 to the 2. But then the next number is we think there's probably about 65 of those for ratio 5. So game to play at home. See if you can find your own multi-perfect number. Thank you, everyone.
Amazing. Amazing. I absolutely I love a sequence that goes 1, infinity, 6. Like that's like the start of any good sequence, of course. Fantastic. That was so much fun. And there's something about this sort of just live scribbling that kind of it almost feels like you're doing the maths yourself a little bit, but it's really, really nice to see and very cool that someone watching kind of chipped in with that. Like, does that happen a lot? Is that a common occurrence on your streams or?
Yeah, especially because, well, I'm on stream and I make a lot of mistakes. I'm kind of terrible at maths, especially when I'm presenting it and I have to do something complicated like work out the factors of 7. And people in chat are really good at correcting me and also being one step ahead to find out where things were going. We had a little sort of competition going for who could find a 5 perfect number first, chat or me. And it was definitely chat by such a
Wow.
way.
Yeah, I mean, like people forget how collaborative maths is, right? And if you're working something out, having a bunch of people standing behind you going, "That's a minus," like it's literally what you need, right? It's how to do maths effectively. I love it so much. Also, from now on, I am going to remove the words numerator and denominator from my vocabulary, and it's just upstairs and downstairs for fractions from now on. That's so
I
good.
can't remember which one's which, Katie.
I don't know. Yeah, I don't know. Numerator and denominator. Like I just know which way around it is, but there isn't really an obvious. No, no. Upstairs and downstairs is much better. I love it. Fantastic. So thank you very much to James. I'm sure everyone in the chat is showing appreciation for this. And yeah, if people want to find you, we'll put a link to James's Twitch channel, which has already gone in, but we'll put it in again. If you want to watch this happening. Apparently, this happens all the time. You can just go and hang out with James and do some interesting math stuff. Further developments in the chat. So there is a maths jam in Leeds. If anyone was wondering about this, it was running for a very long time. I think it was one of the ones that didn't really survive the pandemic, but there has recently been interest in reviving it again. So if you are interested in joining a maths jam in Leeds or in any place, you can just put the name of the city at mathsjam.com. And if there is a maths jam there, the organizer will get your email. If there isn't a maths jam there, I will get your email. And then I will know that you would like there to be a maths jam there so we can start a conversation. But anyway, aside from that, the most important thing for you to know is that this show is free, but we are taking donations, which is to raise a little bit of money to put towards the people who've kindly given up their time to perform this evening. You know, it's nearly Christmas. It would be really nice to be able to give everyone just a little something to cover the cost of an eggnog. So if you've enjoyed this show so far to the value of an eggnog or greater, then feel free. I don't know how much an eggnog is worth. That's not a unit of currency. I've no idea. But to whatever extent you found this interesting and or fun and or exciting so far, think about that either straight away now or wait till the end of the show. If you're watching this back as a recording, just whenever, just right now or whenever, please do head to ko-fi.com/Clopen Mic Night, which I hope is still on the screen, or else that's going to be a really stupid gesture. But we will. I'm sure that the tech team behind this team, so Matthew Scroggs, who's been mentioned already once, is capably operating the tech behind the scenes as well. So if you are watching, wave at your screen, I guess, and Scroggs will perceive that and feel the love and the enjoyment from that. Cool. I reckon it is time to bring on our third act. So if you are there hiding, hello, Ophelia. You'd like to appear out of nowhere. Excellent. Welcome.
Hello.
So I've invited Ophelia to come in. I think because people often say things like, "Oh, I'm not a mathematician." Everyone's a mathematician, right? Everyone is doing some kind of maths. And I'm very excited because even though this is kind of not a maths talk in any sense, I've already seen a sneak preview of, and there's some stats in it. There's all kinds of stuff. This is going to be really, really enjoyable, and I'm looking forward to hearing all about space. Not all of space. You probably can't fit that in 8 minutes, but we'll see how much of space you managed to get through in that time. Go for it. Take it away.
Great, thank you very much. Yeah, so I'm an astronomer, and I mean, you'd think there's a lot of maths in it, and I recently finished my PhD, and I only did one calculation during my whole 4 years. So yeah, anyway, it's no secret that my favorite planet is Jupiter. So I get really sad when people say Jupiter is a failed star. It's just not massive enough to start shining. But no, Jupiter is an over enthusiastic planet, and it's definitely the best planet in our solar system. I truly believe that everyone should be awed and inspired by Jupiter, and I don't think it's very hard to see why. Firstly, no planet spin is as quick as Jupiter's. One spin takes 9 hours and 55 minutes for Jupiter. So a day on Jupiter is less than 10 hours long, which is good. You know, like you don't have to spend so long at work or at school. And Jupiter, of course, biggest planet in our solar system. No planet is as incredibly big as Jupiter. You can fit 11 Earths along Jupiter. And if it was hollow, you can fit more than 1,300 Earths inside it. The second largest planet in the solar system, Saturn, can only fit 750 Earths. So no competition there. And I think no planet is like Jupiter. Look how pretty it is. So all of these images were taken by the Juno spacecraft, which is orbiting around Jupiter. It's been there since 2016. And here you can see some of the stripes on the planet. So these stripes are caused by different chemical compositions in the atmosphere, different temperatures as well, in different parts of the atmosphere. The light colored bands are called zones, and that's where you've got gas rising upwards. The dark colored bands are called belts, and that's where you have gas sinking. The middle picture there, you've got cyclones and vortices at the south pole of Jupiter. And I just think it looks like a painting, right? You can just hang it up like a piece of art. And Jupiter doesn't just look good in the visible light. So here we've got pictures of Jupiter in infrared and ultraviolet light. So these were all actually taken at the same time. So you can see the Great Red Spot there, which is the biggest storm in the solar system. It's about the size of the Earth. Again, we can see different features here. So using visible light, like that our eyes can see, we can see details on the surface of Jupiter's atmosphere. Looking into the infrared, you can see how thick these cloud layers are. So where you see the golden streaks, that's where the clouds are thinner. And then we can see the heat from underneath shining through. And the Great Red Spot actually in the infrared picture almost disappears. You can just about see its outline there. And then the ultraviolet tells you how high up certain particles are. So wherever you see red, we're looking at particles that are higher up in the atmosphere. And then blue, we're looking sort of lower down in the atmosphere. Now, I'm an X-ray planetary astronomer, so I look at planets in the X-rays. And I do have a picture of Jupiter in X-rays. This is one that I took, and I hope you like it. This took about 40 hours. This is a 40-hour-long exposure. And there it is. Yeah, a little bit pixelated, but actually, none of the planets look particularly good in the X-rays. We do just get like little dots for all these planets. And look, even like Uranus, we've just got 5 photons there from Uranus. So a photon is this packet of light. So we've got 5 bits of X-rays there from Uranus. But actually, even a picture like that can tell us a lot of information. So here we've got Jupiter again from 2 different times. So Jupiter's atmosphere scatters or reflects X-rays from the sun. So when the sun is really active, it's giving off a lot of these X-rays, and then they're bouncing off Jupiter's atmosphere. So in the picture on this side here, we can see Jupiter looks very bright in X-rays because it's reflecting a lot of these X-rays from the sun. And then in this picture here, the sun wasn't very active. And so there weren't many X-rays around for Jupiter to bounce off of. And not only that, we've got X-ray aurora on Jupiter. So northern and southern lights. And they don't just come in X-rays, actually. And no planet has aurora like Jupiter. So this picture here is to scale. We're looking at the southern lights at Jupiter and at the Earth. Look how tiny the Earth is compared to Jupiter. We can fit the whole of our planet inside the northern and southern lights of Jupiter. And Jupiter's aurora are the biggest and the brightest and the most energetic. If somehow we could harness all of that power, we'd solve our energy crisis. We can power the whole of civilization just using Jupiter's aurora. And again, we can take videos of these light shows. They tell us a lot about what's going on around Jupiter and also what the sun is doing. So again, we're looking at two different times here. On this side, the sun was very active. So Jupiter was hit by this strong gust of solar wind. The solar wind is this stream of particles from the sun and magnetism from the sun as well. So it slammed into Jupiter. And we can see how the ring of light here is very bright. It's very thick. And we've got lots of activities going on here, lots of explosions of light. Whereas on the other side, the ring of light is a bit wider. It's not as bright, not a lot going on here. So the solar wind in that case was very weak. So not only can we learn more about Jupiter, we can learn more about the sun. And here are all of Jupiter's northern and southern lights and all of its different forms. So we talked about the X-rays, we talked about the ultraviolet. It gives off visible light as well, just like the Earth. So theoretically, if we could orbit around Jupiter, we'd be able to see Jupiter's visible aurora. It also gives off infrared light and also radio waves. And you can actually listen to those radio emissions as well. Now, okay, Jupiter has recently lost its crown. It no longer has the most number of moons that Saturn now has got, like 146 or something. But still, 95 moons is a lot. And they all come in different sizes. They have their own peculiarities. They behave differently. The four biggest moons around Jupiter are these ones. Together, they're known as the Galilean moons. You've got Ganymede, Callisto, Io, and Europa. So Io, the most volcanic place in the whole solar system. Every second, these volcanoes release 1,000 kilograms of material out into space. And Ganymede is bigger than Mercury. Ganymede is literally planet-sized. And the really interesting things about Ganymede, Callisto, and Europa is that underneath the icy crust is a global sea of liquid water. And they are some of the best places in our solar system to look for life. And that is why NASA and the European Space Agency are sending a couple of spacecraft their way. They're going to get there in the mid-2030s, and they're going to see if they have the right conditions to host life. And finally, no planet can kill you like Jupiter can. Average temperature there, minus 145 degrees C. And it's got the strongest radiation belts out of all the planets. And that's because it's got the strongest magnetic field, and they accelerate these charged particles, the electrons and protons, to really high energies. And the strongest part of the radiation belt is close to the planet. So Juno will pass through that part of the radiation belt, and it's going to get the equivalent of about 10 million dental X-rays when it passes through that bit of the radiation belt. And finally, Jupiter, well, the only place we've sent Lego to. So on board Juno are these special Lego pieces. We've got Galileo, who was one of the first people to look at Jupiter through a telescope. We've got Juno, after the spacecraft is named off, and we've got Jupiter itself. And just to conclude, well, there's just one planet in the solar system that's got all of it down, and its name is Jupiter.
Amazing. Amazing. Absolutely fantastic. Again, we're just imagining applause. We're imagining rapturous applause from everyone who's watching. If you are sat in a room on your own watching this, you don't have to actually clap. But if you can just sort of send some vibes of applause to us, that would be amazing. That was so good. I can't believe this Lego on Jupiter. That's like the best fact I've learned so far today. That is excellent. I'm definitely on board the pro Jupiter team. I don't know, Team Jupiter, let's say. The thing I want to know is, how did Saturn gain a whole bunch of moons? Like, were they just not known about before, or?
Yeah, just our telescopes got better. People
Right.
keep looking for them. So yeah,
Oh, well, they can't be that good then if we couldn't see them before. Like, if are they just tiny little crap ones that,
they are.
yeah,
Yeah,
okay.
tiny
Yeah.
crap one. Let's say that.
Yeah, so Jupiter's still winning on moons. There's definitely some discussion in the chat. People are very angry at Saturn for for having overtaken Jupiter. I love it. Excellent. Excellent. So if people wanted to come and see you talk about space in real life, where would they be able to do that?
Um, I still currently work at the Royal Observatory.
Okay, is it in Greenwich?
In Greenwich.
Yeah.
But I will be moving to Dublin soon to start a
Ah,
postdoc. So
excellent. Oh, that's fantastic.
yeah.
This is the other thing. Like, it's so great when someone has slides and they're showing stuff, and there's just casually the credit underneath one of the images is just yourself. Like, it's like, oh yeah, I did this. It's amazing because this is your actual research, right? This is stuff that you've been properly sciencing.
Yeah.
Amazing, amazing,
Thank
cool.
you.
Well, thank you so much for coming and sharing that with us. That's been really fantastic. Feel free to disappear back into the internet, and obviously stick around, watch the rest of the show, but from, you know, not being visible on screen. I think that was all the thing. You know what I was going to say? This is the thing I've been thinking about this all day. So we have if you haven't heard about this or seen this, another of the many projects that I'm involved with that also involves Matthew Scroggs, who's behind the scenes, just occasionally putting up the donation link, just totally at random, any time it could happen. One of the other projects that we do is a thing called the Finite Group, which obviously we picked the name in very much the same way as we picked the name for the Clopen Mic Night, which is just to pick a stupid bit of maths. And the Finite Group has like a Discord chat where we talk about various different things. And the question that came up today was, if you're talking about like I can't remember which one out of cardinals and ordinals it is, where it's the nth thing. So it's like the first, the second, the third. And if you've got n things, then the last one in that list is the nth thing, right? What do you call the one after that? Because like some people were like, well, obviously the n plus one thing, the n plus one thing, obviously. And then other people were saying, oh, n plus first. I was like, I've never heard anyone say n plus first before. That's ridiculous. I would like to start a fight in the YouTube chat. So if you have opinions about this, what do you call the n plus one thing? The nth plus one? Someone suggested. Have your own opinions. That's a discussion for you to continue having in the chat. But obviously, while also very patiently listening to and watching our final act, who I will now introduce, please welcome Luna.
Hello.
Hello.
Is this on?
It is.
Perfect.
Everything is
Excellent.
on. Everything is great. Are you happy?
Yeah,
You've been
I'm
very
good.
patiently waiting throughout the whole show. Have you enjoyed the show so far?
Yeah, it's been fantastic.
Good.
Absolutely
Cool.
fantastic.
In that case, let's continue in that vein. Please
Fingers
do a
crossed.
thing. Yeah, we'll see how it goes.
Yeah. So I told Katie that I was going to be talking about floating point arithmetic. And then about 3 days ago, I completely changed my mind. I decided I didn't want to talk about how computers are absolutely terrible. And instead, I wanted to talk about something that I actually really like. So over the summer, I got really obsessed with this game that you might have heard of called Tetris. If you've somehow been living under a rock for the last 40 years, you have this playing field on a grid. You have these shapes that fall down from the top of the screen one at a time. You move them left and right, and they kind of pile up at the bottom of the screen. And your objective is just to fill in like lines of shapes. And once you've got like a full line of squares, that line gets cleared out from the screen and everything shifts down and you get points. And it's basically just an endurance game. You've probably played it. But I got obsessed with this over the summer, to the extent that like when I closed my eyes, I was going to sleep, I was seeing the shapes falling. And I started like idly doodling them, just like on a grid, just seeing what patterns I could come up with. And I started reading about tilings as well. And I encountered this concept of fault lines, which is when you've got a straight line that cuts straight across a tiling and doesn't like intersect any of the shapes. It's just going along the edges. And so I started playing around with like ways of constructing tilings that don't contain fault lines. So here's one of the ones for a 4x4 tiling of tetrominoes, i.e. shapes of 4 squares. That's quite nice. There's a few others for 4x4 with tetrominoes, but they kind of fall into the swastika problem of fourfold symmetry, which is rather unfortunate. And then I found myself kind of exploring other sizes and shapes as well, and considering where could these fault lines happen. So if I look at a 4x3 grid, for example, I can't get a vertical fault line down the middle, because now I've got 6 squares on the left and 6 squares on the right, and you can't divide 4 into 6, not evenly. So there's always going to be at least one shape that bridges across that fault line. But I could get a horizontal fault line, for example. I could have, a line piece there and then 2 squares underneath it, or, perhaps 2 L pieces underneath it. And then I started thinking, well, what if I go beyond tetrominoes? What if I introduce triominoes, shapes made out of 3 instead? Now I can put vertical fault lines because 6 divides 3. But I can't get a horizontal one because along this top row, if I put 3, now I've got a square on its own that has to connect somewhere. So I can't get a fault line across like that. And I start getting patterns like this. So that's a nice fault-free tiling for 4x3 made out of triominoes. And then I started thinking, okay, well, is it possible to do that with just the L tiles? Because, I don't know, I was curious, and we'll give it a go. So let's make a rectangle that's 3 tall and n wide. And let's put an L tile in the middle of it. And then consider this space here. There's only one way for me to reach that, which is like that. And now I've created this thin gap at the top that I can't fill with L tiles. Okay, so that's not going to work. What if I put one up here? And then again, we consider the kind of the lone square down there. If I do that, well, okay, now I've made a rectangle, but if I want this to be part of anything larger, now I've got these big vertical fault lines, so that's not going to work. What if I put it this way instead? Okay, well, that seems to tile nicely, and I can kind of continue this pattern on. But here's the problem. This works if I tile it out to infinity, but as soon as I put a wall on the end, now I've got 3n plus 2 squares on the left. Like, these aren't going to work. And similarly on the right, I've got this kind of leftover square that I can't really do anything with. Because if I fill that in, now there's just another leftover square, and so on, and that will keep going. And if there's a wall on the right-hand side, then that's a problem. Okay, but this can still tile out to infinity just fine. And then I start thinking, well, what if I want to do this in both directions? What if I want to have just tiling the plane with these shapes? So I can start doing that as well. And I can orient them all the same way, and that kind of works. Or I can start orienting them backwards, and that's kind of nice as well. Or I can start doing, like, I don't know, 90-degree rotations on that, and that kind of works as well. But I found a really, really nice one that works kind of recursively. Because if I put 4 L tiles together like this, I've made a larger L tile. And this doesn't have any fault lines. So what if I then put 4 of these together? Still no fault lines. And if I fill all of that in, still no fault lines. And I can do this out, ad nauseam all the way out to infinity. And I just think that's really satisfying and neat. None of this, of course, actually made me any better at playing Tetris. I got kind of obsessive about it in the hopes that it might, help my spatial reasoning and make me actually be better at the game. Didn't help at all, because my brain just goes into like impulse mode when I'm playing. But I do have a puzzle that I'll leave you with. Because if I tidied this all out, it's really satisfying when you're playing Tetris if you can set it up in such a way that you've got this nice gap, and then you can drop a nice long line piece down into that gap, and then you clear 4 rows at a time. And that's just really nice and really, really satisfying. And I want to know if there's a way that you can do that from the very start of a game with a completely fresh board. Could you set it up so that you have something like this, and then you can drop a line piece in? Now, the easy way would be, well, sure, just make it all out of line pieces, right? Unfortunately, the random number generator in Tetris doesn't let you do that, because it doesn't pick a random piece every single time. It does something kind of neat. What it actually does is it puts all 7 possible pieces into a bag, and then it will draw them out randomly one at a time. So it'll take those out randomly one at a time, and then once all of those 7 have been used up, then it will replenish the bag and start over. So the first 7 pieces in play in any game of Tetris will be 1 of each in some random order, and then the next 7 will be 1 of each. So here's my question. Can you make a setup like this, where you've got this nice thin gap to drop a line piece in out of the first 10 blocks of a game? And what pieces would you need? Can you say anything about which pieces you would need in order to be able to pull that off? And I'll leave you with that.
Excellent. I can't believe you just set a puzzle because now I'm gonna have to try and think about that. That's amazing.
You're welcome.
I just had this vague hunch that if I invite the person that often turns up at the pub with a tablet and just goes through these lovely explanations and doodles stuff, and it's really interesting, that you might just be able to do the exact same thing here on this stream. And this has gone really well. I like that very much. And I hope people. Oh, there's a question in the chat. How wide is the Tetris
How wide
board?
is the board? The standard Tetris board is 10 blocks wide.
10 blocks wide. So that's why I guess it's 10 pieces because you've got 40 squares to fill. And I guess the 10th one has to be the eyepiece that goes in last.
Yes.
Okay. That's going to keep ticking away in there. Fantastic. So yeah, we've got a link in the chat going to Luna's website where you can find out other things. She does lots of excellent other things. Lots of good lightning talks, I think, is a thing. Which you can find various of on the internet. But yeah, thank you so much for coming and sharing that with us. That's really cool. And I imagine other people are also going to be playing with that puzzle for a little while. But yeah, I think that is the fourth of our 4 acts. So thank you very much once more, Luna. So there's a couple of tiny more housekeeping things to say before I finish the show. Again, if you would like to be updated about future shows, possibly the easiest way for us to tell you when the next one of these is happening is if you jump on our mailing list. So if you go to clopenmicnight.com, scroll down a little bit, there's a little, I believe, blue rectangle where you can drop your email address. We will just use it to tell you when there's another Clopen Mic Night. The other thing to say is that we have a feedback form. So if there's anything you wanted to feedback, if you found anything cool related to any of the things that people have said that you would like them to know about, or if there's any other bits of, it's essentially the feedback form is what was good, what could be better. And we're happy to take general comments about the entire show, about the way the whole thing runs, or anything about any of the acts. If it's too horrible, we won't pass it on to them, but please be nice and helpful and supportive and constructive. But we will put a link to our feedback form in the chat just so that you can, if you would like to feedback on there. Again, find us on Twitter, find us on Mastodon, find us on Instagram if you would like updates. And potentially, I realize it's been a little while since the last one of these because it was last September. We've been busy. It's been a whole thing, right? Everyone's had a bit of a year, but hopefully we will try and get another one of these together. If you are someone who does talk about maths on occasion or has mathematical things to share, again, drop us an email, hello@clopenmicnight.com. You're very welcome to contact us about potentially if you wanted to come and do a thing like this. We can definitely consider submissions from people, and also on our website there is a backstage area where you can find a form to submit suggestions for segments. So that's all of the things that I have to say. I believe this is the worst way to end a show ever, but it has been a very long year, and I'm just tired. But I hope you've enjoyed the show. I hope you've had a fantastic time. Thank you so much to all of our wonderful acts. Thank you to Scrogs for hiding behind the scenes. Thank you to Kevin and Ben who've been lurking in the YouTube chat and posting useful links. And thank you to everyone who's been joining in there and chatting, and to everyone who's watching both live and recorded. I don't know when you're watching, but we will leave this recording up for a little while, potentially sort of around a month-ish, just so that people can watch it offset in time. But otherwise, thank you very much for coming, and I hope you've had a great Clopen Mic night. So until the next one, goodbye.